So on the left side, these are all regular equations, normal things that we should already know how to solve. You don't have to confess to me now if you don't, but I think you do. So I'm going to add 7 and add 7. Or I can think of moving the 7 to the other side. Now in this case, I can actually add 8 plus 7, so I get a nice answer of 15. Here, if I want x by itself, I need to, just like I needed to get rid of negative 7 or minus 7, I need to get rid of minus b. So just like I did there, to get rid of minus b, I'll add b. Or, once again, you can think of it as moving it to the other side, and when it moves over, it changes its sign. It just isn't something we can simplify. You could have also written b plus a. So I could write x equals a plus b or x equals b plus a. Bless you. So in 2a, we would need to divide. So whatever we need to do to get the x by itself, that's what we're going to do on the right side also. And so sometimes there can be some numbers involved, but there's still more than one variable. So I need to divide by negative 3. But since we don't know what m is, that's just what the answer is going to look like. So you may get to where you don't even need to write this step in the middle, especially when it's one step. It's just kind of like when I move this over, this is what it would do. So now we have some that are 2 steps. So we would undo that subtraction first. And the same thing over here. I would undo the subtraction first. On the left, of course, we can actually add 11 and 5 together. Over here, I can't add them together. I'll just write them d plus 9. And then I need to divide both, actually on both equations, by 2 to get the variable by itself. On the left, we can actually simplify 16 over 2 to write 8. Over here, I can't simplify that, so it is just b is equal to d plus 9 over 2. You could split that into 2 fractions, and there are times that that can simplify some. So, for instance, if this had been, I don't know, something like 4d plus 8, and 2 can divide into the 4 and into the 8, then I would simplify. But you would really only want to do that if it divided equally. So this answer could also be written this way. There will be times when we're doing equations in slope-intercept form that we will have to split it up, but if you're just solving the literal equation, you can just leave it in one big fraction, which is probably the simplest thing to do.
So if it would have been like d plus 8 by 2,
Mm-hmm.
so how could we simplify it?
Okay, so let me rewrite this up here. All right, so the question is, what if it had been d plus 8 over 2? Now, because the 2 does not go into both, it would still be acceptable to just leave it in one fraction. Or I can do d over 2 plus 4, and 4 would be out of the fraction then. So basically what that does is split it into 2 fractions and allows you to divide the second part.
So this would have been the answer, d by 2 plus 4.
Mm-hmm. And again, since the 2 does not go into the both terms, you can still leave it, it would be an option. You can still leave it in one fraction, but if this said this, then if it goes into both, then I need to actually do the division and say d plus 4. So if all the parts could simplify, then I'm required to simplify. I don't know that we see too many that are going to do that, but just kind of as a heads up. And then, of course, if there is division, we need to multiply. So just like before, how we multiply by negative 8. So x is negative 88. Over here, I need to multiply by 3. So on this side, it gets rid of it. And, I mean, I guess you could write h dot 3, but I think it's going to be probably easier to read if we write 3h. I know what I wrote kind of looks like h to the third, but it's not h to the third, of course, if multiply. So we have some more two-step here. Still trying to gotta pay attention. So when it's just one variable like what we've dealt with before, we know what we're getting by itself, right? I know that I'm trying to get x by itself. Why did I just do that? Sorry. That would have not gotten x by itself. I want to subtract 26. Because you want to move things away from the variable. And then, of course, divide by 2. So over on the right, I have to know which variable, because there's not just one by itself right now. If there's one by itself, we know that's not the one, or it would be finished. So if I want to solve for v, that means this is the one that's going to stay put. I need to move the things away from that, so I'll subtract 5. Or you could think of it as moving the 5 away to the other side. When it crosses the line, it changes its sign. And then to get rid of the 7, it's multiplication, so to get rid of it, we will divide. And we don't have any way to simplify that. 7 does not go into 3, 7 does not go into negative 5. So once we've canceled the 7's out, that really is our answer. So it's not going to be as pretty as just a negative 6. You could see that same equation, 3d equals 7v plus 5, and it could say solve for d. And if it said solve for d, we would have just divided both sides by 3 and been done. It would have been an easier problem. So the ones like number 6, there's a couple ways to do it. Normally, there's a couple ways that we could do it, and they're going to look a little different in our answers, though. So I could, since there's nothing else outside the parentheses, I could divide first, which is not usually our process there, but I could, because there's nothing outside the parentheses besides the 3, and then add 4. Or I could distribute, add 12, and divide by 3. When it's just numbers, the answer comes out looking exactly the same. When it's literal, the answer is not going to be written quite the same, but it is still equivalent. So I need to solve for p, so sometimes it helps me to kind of underline or somehow mark for myself, like, which one am I trying to get by itself? So I'm trying to get p by itself. Good morning.
Good morning.
So if I follow the first way I did it, I divided both sides by 5. to get 4x plus p is equal to w over 5. And then if I want p by itself, I would be subtracting 4x. So I get w over 5 minus 4x. Mm-hmm.
But I'm not going to Richmond again. I wonder.
And then if we decided to distribute first, okay, so just to acknowledge you can do it both ways, I'd have 20x plus 5p is w. Then I would need to subtract 20x. So I would have 5p is w minus 20x, and then divide both sides by 5. And then these cancel out, so in the interest of space, that's my answer. Do you guys see like those answers look different, but they really are the same? Because if I split the fraction on the left up, the 20 could divide by 5. Because w doesn't divide by 5, it would be okay to leave it in that big blob. So either way, the answers look a little different. They are equivalent. You're okay to do it either way. So for 7, we'll subtract 2. And then divide by 3. The one on the left should be like, just like review. It's just to remind us of the order that we do those steps. Notice both of these we're solving for y, so they kind of placed it in the same position. So here we would subtract the 4x, because we got to pay attention to which one we're supposed to get by itself. Nothing magical about it being y. It could have said x instead. And then I could write 12 minus 4x or negative 4x plus 12. There are going to be some times when we're going to want to write the x next to the equal when we're graphing equations, but for now it doesn't matter. And then divide it all by 2. Now, this is one because 2 does go into both of those. We will want, you have a new packet, we will want to actually divide. So 12 divided by 2 is 6. 4 divided by 2 is 2. So if the number on the bottom goes into both, then I need to actually simplify. But if it only goes into one of them, it's your option to simplify that part of it. Sometimes it's preferable if there's going to be a fraction to just have it all in the fraction. And then the back side of that.
This is not for me. In my bucket.
Oh, okay, thank you. Are you sure it wasn't? Are you sure it was in yours, or did you take these things out of a different thing? Okay, so the next page is an assignment page.